Welcome to the solutions video for homework assignment 3.08 number 1. So in this case, the homework is questions 1, 2, and 3 from section 8.5 of the textbook. We have a cuckoo clock hanging on a wall, and we need to plot the data and determine the equation of a sinusoidal regression function that models the movement of the pendulum. Now, there are many software packages that can do sinusoidal regression. The Google Sheets spreadsheet is not one of them. So for this, we're going to go directly to the calculator. So I start by entering our data into list 1 and list 2. Then I go to our stat menu and into the calc menu, and I scroll down until we find sinusoidal regression in option C. Here again we have a number of options. I'm going to stick with the default 3 iterations with list 1 and list 2. The difference is going to be the period. Looking at our data, if we go from minimum to minimum or maximum to maximum, we seem to have a period of 2. So that is the period I'm going to guess. I'm going to give us a regular expression of y1, and then I'm going to calculate. And this gives us a fit for the data. So it looks like an amplitude of 1.5, which is consistent with the data having a max and min of 3 units apart. We have a b term that appears to be pi. Now this c term in the sinusoidal regression, remember, is not our phase shift. It's the negative phase shift multiplied by b. So it looks like it's more like 1/2, and our midline is 66.5. We verify that when we plot this, we are going to have our data plot there. And then we pick our zoom stat window. And we have an issue here. The graph doesn't match. Why is that? That is because our sinusoidal regression is always in radian mode, but we can see here our calculator is in degree mode. So we have to go to our mode and change it. And then when we graph it, we're going to get a much better fit to the data. So remember, the sinusoidal regression on the calculator only uses radian mode. So we have to be in radian mode. So when we fit it and it doesn't look right, check that you are in radian mode, not degree mode. So now, homework question 2. It says a water wheel. I may have shifted it around too much. I was trying to pull the wrong camera. So a water wheel with a radius of 5 feet is 1 foot above the ground. When water falls onto the wheel completes 1 revolution every 2 seconds. So for this, we can get some benefit from our spreadsheets here. So we can take a look. These time intervals seem to be at 0.5. So I can even say right from the start, each point is 0.5 seconds, later than the previous point. Copy and paste that formula, or just use that bottom corner box to fill it down, and there we go. Now we seem to have a period of 2, so we can assume we have an 11 there and a 1 here. Our original data said that this is sinusoidal. It's 1 foot above the ground with a radius of 5 feet. So it makes sense that our max and min would be 11. And then our midline, which goes between, will be 6. So this is going to be how we complete our data. So let's go back to our TI calculator and start entering that data in. Actually, I'm going to leave the spreadsheet visible while we are entering that data in case you are doing the same at home. So you have your source. We're going to take time as our list 1, and not the number of revolutions. So that's our second column, the 0.51, 1.52, 2.5 up to 4. And our height is our list 2, 11, 6, 1, 6, 11, 6, 1, 6, 11. All the Marvel fans are going, 616? What are you talking about? But anyway. So now we can go back to our calculator display. So this is the data that we have entered. And we are again going to go to our stat menu and calculate a sinusoidal regression from the bottom of the list. You can just go up 3 times. The number of iterations is just how long it'll take to get decent results. It usually works well with 3. Now, based on the data we have, our period appears to be 2. So I'm going to store that in our Y1. And then I'm going to calculate based on that 2. And it is giving us a decent looking fit. The amplitude of 5, the midline of 6, that's what we expect. Our B and C terms are consistent. So we will jump to our zoom stat of 9. And with that in there, we plot our curve. And now we have our curve. So this does seem to be a very good fit for our data. So now going back to the textbook questions, we've got our equation. How high is the point at 1.15 seconds? So they're asking for feet and inches to the nearest inch, and then again at 7.2 seconds, feet and inches to the nearest inch. So if we take a look at what we actually had, and go back up to our fit. A is 5, D is 6, B is pi, and if we factor that out, C looks like it's a -1/2. So let's see if we can't reproduce this graph with a graphing calculator. So again, we said A was 5, D was 6, B was pi, and this C is -1/2 with this formulation. So comparing our charts, we need to have an x-axis that goes up to 4. And then we have points at 211 as we expected, and 1, as we expected. So this is fitting the data that we have. So how high is the nearest point at 1.15 seconds? It's about 1.545 feet above the ground. So 0.545 feet is 6.54 inches. So to the nearest inch, this is 1 foot and 7 inches above the ground. And our other point at 7.2 does not fit in our current display. We have to scroll over and find it. And that's 1.955 times 12 is 11.46 or 11.5. So here we have 1 foot, 11.5 inches above the ground at 7.2 seconds. So that is the solution to question 2. Question 3 is going to get a lot more involved. And for some reason, the camera is no longer updating. That is strange, because that page is not visible. I turned this camera around. Let me pause the video while I try to sort this out. Okay, I'm going to have to do this video in 2 parts because I need to close the software to reconnect the camera.